In this 5-part series, I want to go over an introduction to trigonometry. I'm going to start by covering right triangles, and then later on I'll show the connection between the right triangles and the unit circle. So first thing here is some review of triangles. So a triangle will have 3 corners and 3 sides, and the angle measurements will always add up to 180 degrees. Some other things, we'll talk a little bit later about the isosceles and equilateral triangles. And then an acute triangle, the angle is less than 90, where an obtuse triangle, it's more than 90. The other thing that we'll actually use a lot in trigonometry in general is the Pythagorean theorem. A squared plus b squared is equal to c squared. So a and b are representing what's called the legs of the right triangle. So those are the two that are adjacent to that right 90-degree angle. And then c is the opposite side, which is the longest side of the triangle. Okay, before I go over anything else, I want to talk a little bit about similar triangles. So the idea of a similar triangle is, let's say I call this A sub 1, B sub 1, and C sub 1. What makes this similar to the other triangles? And let me actually give those some labels as well too. Let's say that, change the color here. If we've got this length, I'm going to call that A sub 2, B sub 2, and then this length, C sub 2. And I'm going to do this one more time. So now we've got this whole length here will be A sub 3, B sub 3, and then finally this big hypotenuse now will be C sub 3. So these are all similar triangles. So I might call the first one 1, and then the second triangle, and then the third triangle. And what that means to be similar triangles is if you look at the triangles, well, for one, the angle measurements are going to be the same. So if I'm going to call this angle B, maybe I'll call that one a capital B, and I'll call the other angle capital A, and then we've got a 90-degree in the corner. No matter which triangle you look at, those angles are the same. So that's actually one thing that holds true for similar triangles. So all the angles are the same. The lengths are different. So the length of A sub 1 is shorter than the length of A sub 3. But what the lengths do have in common is that the ratios are the same. So that means if we took something like, let's say, the legs of the smaller triangle, maybe writing it as A1 over B1, that actually is the exact same ratio as if we worked out A sub 2 over B sub 2, and the same thing for that third triangle, A sub 3 over B sub 3. And it doesn't matter what ratio we look at, that's still going to hold true. So if I instead did like A sub 1 over C sub 1, whatever value that ends up being, would actually be the same thing as A sub 2 over C sub 2 and A sub 3 over C sub 3. So these are the properties that hold true for similar triangles, and we're going to work a lot with similar triangles in trigonometry. Okay, let's go back to talking about those ratios again, because that's a big part of trigonometry as well. So what we're going to do is try and figure out all the possible ratios that we can create out of these 3 sides. So we've already talked about a couple of them. So we've said A over B is a ratio from the lengths of this triangle. Another one that we might do, which we did on the previous page as well, is A over C. Do you see any other ratios? We could also do, let's say, B over C. And let's not forget with these ratios, like the ones that we've already found, we can also write the reciprocal, which would be another ratio that we could create from this triangle. So maybe B over A is also a ratio from this triangle, C over A, and C over B. So you might keep looking for more ratios, but these are actually all the possible ratios that we can create with the three sides given, A, B, and C. So why is that important? That's important because that's actually the definition of the trig functions. So there are 6 trig functions: sine, cosine, tangent, and then cosecant, secant, and cotangent. So those 6 trig functions are defined by those 6 ratios from the previous page. So here we've got another triangle. Let's focus on this top one to start with. So whenever we have our right triangle, there's going to be a 90-degree in there. That's what makes it our right triangle. But then we also need to figure out which angle are we looking at as the perspective. So you notice here, we're trying to look at it from the perspective of A, and that's why there was that little curve in here. So we're not really looking at it from the perspective of B right now, even though that certainly is an angle in this triangle. But if we have a triangle defined like this, so a right angle, and we're looking from the perspective of A, we would call the side across from that opposite. And then the side that's touching it right here, which is B, is our adjacent side. And then our hypotenuse, I have it written here as A, H, but we might also call that C as well. The hypotenuse is always opposite or across from the 90-degree angle. So that does not change even if we look at this angle from the perspective of B. I'm not going to draw it on here, but we could look at this triangle from the perspective of B, and if we did that, then the opposite would become that side B, and the adjacent would become the side A. Okay, so what are the definitions of the trig functions? So here I've got the full name, and then I have also the abbreviations that we'll use. So sine is opposite over hypotenuse. And so looking at the triangle that I have boxed off in purple here, that would be A over C. The definition for cosine is adjacent over hypotenuse, which, since we're dealing again with that angle A, would be B over C. Tangent is opposite over adjacent, which in this case is A over B. So these are the 3 main trig functions that we'll be using. And so just to kind of go to the bottom diagram that I have here, if you've done anything with trig before, you may have heard the expression SOHCAHTOA. So SOHCAHTOA, spelled SOHCAHTOA, is trying to help with these trig definitions. So the SOH is that sine is opposite over hypotenuse. The CAH is that cosine is equal to adjacent over hypotenuse. And TOA represents that tangent is equal to opposite over adjacent. So that's something that you can use to try and remember these definitions. And again, in this introductory part of trigonometry, there is a lot of memorizing. And this is probably one of the main things. So you want to try and find a way, the more that you have this down without having to look it up, the more comfortable you're going to be moving forward in trigonometry. So that's SOHCAHTOA. I actually always feel like, how are you going to remember how to spell that? SOHCAHTOA is kind of a strange word. You can make up your own, whatever you might think of in terms of trying to remember these definitions. I actually remember my friend in school coming up with something, and it actually just stuck with me in terms of memorizing these definitions. So instead of SOH, she had said sliding over hills. So I'm like, okay, sliding over hills is sine is opposite over hypotenuse. And I think this one, actually I know this one, because that's the thing, we remember these strange things sometimes and we can't get them out of our head, but it was candy and hippies, which I realized doesn't necessarily go together. But it stuck with me, and then that would help me when I was learning, remember, okay, cosine is adjacent over hypotenuse. And I don't think she came up with anything for tangent, but I kind of thought, oh, well, SOHCAHTOA, I can remember how to spell that TOA, that last part of it. So anyways, just invite you to try to think of your own way to memorize it so that you have this down pat for the class. All right, so there's still three more. The three more definitions are the reciprocals. So what I would recommend is just knowing which ones go together. So the last one is probably the most straightforward in that tangent and cotangent, well, the names are similar, so it makes sense that those would be reciprocals of one another. So that means that the definition for cotangent is adjacent over opposite, which is B over A. The other two are tricky in that they don't relate the way that you would think that they relate. And that's, because I feel like, oh, one starts with an S, the other one starts with an S, I want those to go together. And it's actually the opposite. So sine goes with cosecant and cosine goes with secant. So what I remembered when I was learning this is that the S goes with the C. And that helps remind me about which reciprocals go together. So that means if cosecant is the reciprocal of sine, the definition is hypotenuse over opposite. And since secant is the reciprocal of cosine, I'm going to flip cosine's definition around. So that's going to be hypotenuse over adjacent, which is C over B. And those are our trig definitions, and these are going to be getting used throughout the class of trigonometry. Okay, let's look at an example here. Let's say we're given one of the sine functions. So in this case, sine is 4 over 7. So since sine is opposite over hypotenuse, that tells us the opposite side is 4 and the hypotenuse side is 9. So here we've got our angle theta. So that's the perspective that we're looking at here. And you can see our 90 degrees is here. So opposite of our angle theta would be A. So that's going to be 4. And hypotenuse is going to be our value C here, which is 9. Now, if we only have two sides of our right triangle, to find the missing side, which is what we're going to need to find the rest of the trig functions, is we're going to use the Pythagorean theorem. A squared plus B squared is equal to C squared. So that becomes 4 squared plus B squared is equal to 9 squared. So the value for B is the square root of 65. So now let's write all of our trig functions. We already had sine, but I'm just going to write it down again. That was 4 over 7. So actually, without doing the extra work, just knowing that we're dealing with reciprocals, I could get cosecant right away, which would be 7 over 4. Cosine is adjacent over hypotenuse. So we found our B value to be square root of 65. Okay, the reciprocal will be secant, which is 9 over square root of 65. So this happens that we do end up with a square root in the denominator, so we may want to rationalize the denominator. To do that, you can just multiply the top and the bottom by square root of 65. So you get 9 square root of 65 over, and then square root of 65 times square root of 65 is actually square root of 65 squared. And so the square root and squares sort of cancel each other out, which just leaves 65 in the denominator. And then our last two, we've got tangent, opposite, which is 4, over adjacent, which is square root of 65. We can rationalize this one as well. And then finally our cotangent. So if tangent was originally 4 over square root of 65, I'll just write that as square root of 65 over 4, flipping that around. And this is our 6 trig functions, trig expressions for this triangle.